Alright, in some of our previous lessons, we've looked at sketching some circular functions when we've been given a rule for us to sketch, right? Now we're going to go do the exact opposite in today's lesson, right? We're going to find the rule when we've either given a graph of a circular function or some piece of information that can help us work out what's the rule of that circular function. So let's just jump straight into this first question, right? The graph shown has the rule y equals a times sine t plus e, let's call that e, right? They want us to find possible values for a and e. Right, so what we're going to do here is obviously a in this particular rule, y equals a sine t plus e. Right, t is the variable in this question. Right, t and y are my variables. Right, a basically is referring to our amplitude, and the e basically is referring to our horizontal shift in this particular question. Right, and because there's no values for t does not have a coefficient here, which possibly tells me that this could be a very basic sine function, which has a period of 2 pi. Right, so let's go and look at the graph that's been given to us. Right, so it's a sine graph. Right, a sine graph is supposed to start from the mean value. So if I take into account this particular graph that's been given to us, I could possibly see that the sine function can start here and finish at this particular point. So that's going to give us a really nice looking positive sine graph. And obviously, because we're starting from pi on 3, I can conclude that the sine function has been shifted by pi on 3 units to the right. Right, so that's an information I can conclude just by looking at this particular graph. This particular sine function is starting at a positive pi on 3, which means there is a horizontal shift of pi on 3 units to the right. Right, now looking at the maximum and minimum, right, looking at the maximum and minimum of this particular graph that's been given to us, I can quickly conclude that the amplitude, right, given that the mean value is at 0, my amplitude is going to be equal to a half, or 0.5. You can write it as a fraction or as a decimal. Now the other thing I've got to quickly establish is what could possibly be the period of this particular function, right? So if I could look at that, right, so half a cycle has been completed from pi on 3 to 4 pi on 3, right? So 4 pi on 3 minus pi on 3 is basically 3 pi on 3, or in other words pi, right? So that's the distance for a half cycle, right? So which means the distance for a full period or a full cycle is going to be 2 pi, right? From that I can quickly ascertain that the period of this particular function is equal to 2 pi, which is what we anticipated when we just quickly looked at the rule. Right, so which means what I can conclude from here is obviously the value for a is going to be a is the amplitude, so a is going to be equal to a half, right, or 0.5. Now because we're moving pi on 3 units to the right, and given that they've used a positive sign inside the bracket, right, what we've got to make sure is we've got to represent the value for e as a minus pi on 3, right? So which means if I quickly rewrite this rule with the values for a and e, we're going to have y equals a half sine t minus pi on 3, right? So that's going to reflect an horizontal translation of pi on 3 units to the right. Right, so that concludes this particular question, right? So you're going to get a mark for that and a mark for finding the value for e, right? So in this particular question, they haven't asked us to rewrite the equation, but my suggestion always is when you find some values in a rule, always rewrite the rule with those values, so it makes it look neater, right? Now let's jump into the second example, right? So the second example is talking about, alright, to start with, we don't actually have a graph, right? So that's the challenge in this question. So they're saying a function has a rule y equals a sine nt plus e. Alright, so again in this particular case we've got 3 missing things, a, n, and e, right? So where a again is our amplitude, because t has a coefficient of n, the period might not necessarily be 2 pi. So we might have a value for n. It could end up being 1. I could be totally wrong, but it might not have any other value other than 1, right? So that's got to come from our period, right? We also have to take into account that E is not a straightforward horizontal shift in this case, right? Because in previous examples that we've done where we've got the value for n inside the bracket, what we've basically done, we have gone a sine, we've taken that n outside the bracket, leaving us, in this case, it's going to be with t plus e over n, where e over n is going to be my horizontal shift. Right. Right. Let's go into the question. What else? What are the informations given to us? Right. They're saying the range is minus 2 pi to pi. So the range is minus 2 pi to 6. My bad. What am I talking? Right. Minus 2 to 6. So that tells me the maximum 6. The minimum is minus 2, which takes me to the mean value. Right. 6 minus 2 is going to give 6 plus minus 2 is going to give us a positive 4. Right. Positive 4 is so. What I'm talking about here is, so we've got a minus 2 and a positive 6, right? So the distance between them is 8 units, right? So the distance between them is 8 units, right? Which means the mean value is going to be sitting at a positive 2, right? So that's going to give me my amplitude of this particular function to be equal to a positive 4, right? So that gives us, we've solved one alphabet already, so we've solved the value for a. Right, now they've also told us that the period of this function is equal to 8, so the period is equal to 8. Let me just use a different color just for the sake of it. Right, so period is equal to 8, right? So in other words, the period of a sine function can be given by 2 pi over n equals 8, right? So if I simplify for n, so I'm going to have 2 pi on 8 equals n, right, which gives me the value for n as pi on 4, right? So with that, we have simplified 2 of the 3 items. So that's my value for a, right, which is the amplitude, and my value for n is pi on 4. Alright, so with that information, so we just still have to go one more, right? The other information we have to find out is the value for e. Right, so if I take into account the value for e, they've given us one more additional piece of information. They're saying when t is equal to 2, y is equal to 2. So we're going to substitute that straight into this rule. Right, so first I'm going to do is I'm just going to rewrite the rule with the values for a and n. Right, so let's do that. Let's start by doing that. So y is equal to 4 times sine nt. So I'm going to have pi on 4t plus e. Right. And then we're going to substitute the coordinates given to us. The coordinates given to us is when t is equal to 2, y is equal to 2. Right, so let's substitute that. So when t is equal to 2, y is equal to 2. So I'm just going to go on to the next page here. Right, so I'm going to have y equals, so 2 equals 4 times sine. We're going to have pi on 4 times 2 plus e, right? So solving, we're trying to solve this for e. So we're going to divide both sides by 4 to start with. So I'm going to have 2 divided by 4, which is going to be equal to a half, equals sine. So pi on 4 times 2 is going to be pi on 2 plus e, right? So pi on 4 plus e, right? Now that's going to be testing your knowledge on complementary angles, right? When we talked about complementary relationships in one of our previous lessons, right, that's going to be really important in this particular scenario, right? Because don't know how many of you can remember this rule. When we have a complementary relationship of sine pi on 2 plus e, now pi on 2 plus e is going to take us into the second quadrant, and in the second quadrant we are well aware that the sine value is positive, right? So the complementary relationship is just going to be equal to cos e, right? So that's what we're going to use in this particular scenario. So let's do that. So I'm going to have a half equals cos e. Alright, now quickly revisiting my values of sine and cos and tan in the first quadrant. When is my cos function equal to a half? I can quickly ascertain my cos function is going to be equal to a half for a value of pi on 3, and that helps us to solve the value for e in this particular question, right? So now that we've got the values for all three, like I did in the previous example, I'm going to rewrite the rule with all three values. So y is going to be equal to 4 sine. Now n was, from memory, what was n? N was pi on 4. So pi on 4 t, and e is a positive pi on 3. So positive pi on 3. And that completes this particular question. Alright? I hope that helped you with finding some rules for circular functions. Thank you for watching and have a lovely day.